the x value. Use your calculator just to get used to you seeing the caret. Caret's right below the clear. Round 3 decimal places. You can use pi as an exponent as well. You can use a radical as an exponent, a fraction. It's kind of gets you used to putting these in. Your calculators, if you have the 84s, they're nice. They give it to you right up top. The black ones give you the caret and then the other part. So if you have one of the 83s, don't forget you have to, when you raise this, you have to put this in parentheses. Okay, so just be careful of that. Stop me if you have any questions. Otherwise, I'll assume everything's pretty good. And for you guys that were in here yesterday too, we just went over your basic characteristics of an exponential function. We just took a couple of different bases and we saw that they behave the same. So for our purposes, our sketches will look very similar to this. If it's the larger the base, the closer it rides to the y-axis. But the most important parts are your asymptote, your y equals, your intercept, your 0, 1, and domain, all real numbers, and range 0 to infinity without using 0. So they follow the same type of characteristics. This one would be an increasing if we use the negative, which gives us a reflection. That guy's a decreasing. So just so that you just get used to describing and seeing these. Algebra 2, we tend to put everything in your calculator. Everything has to have definite points on the regions. They have to see the points. Pre-calc, we basically sketch everything. So just to get used to that part, I thought this was just a little introduction. Again, watch your asymptotes. They behave the same. The goal of this is to get you to see that they behave the same. Finding these guys, 17 was D, and I don't know if it said find the intercept or find the domain, whatever it said here. Oh, you just have to match them up. Try to match them up using your transformations. Okay, then these guys brought us back to transformations. Your core graph is your basic function. If it's next to the x, it's going horizontally the opposite way. Horizontal does not change your asymptote, but it will change your y-intercept. So make sure algebraically, and we always find your intercepts algebraically. That's not going to change. The only thing right now is you can't find your x-intercept algebraically. Because if we did that, we'd have to do this. And you'd have to use a log to bring it down. So we didn't do the log part of this yet. So right now we're not solving your x-intercept algebraically. If you want to find your x-intercept with your graph, that's fine. But as soon as we get to the logs, we'll go back to solving the x-intercepts. So make sure you note that it's an increasing where the domain, the range is. That doesn't change in a horizontal shift. Neither did your asymptote, just your intercept. And was there just two? Just two. Okay. So again, the first one took a horizontal shift to the right 2 and then down 3. So again, you changed your asymptote. Your asymptote, if it's easiest, your asymptote starts like this, shift it down 3. Any horizontal change will not change it, but any vertical change will. If your domain is all real numbers, that's not affected. If your range is here and your shift is down, shift it down 3. And that'll help you go right over those. And again, your intercept, just plug in your 0 and you can just calculate that right on your calculator. You okay with these? Just basic sketching, just to get you back into your, we use the natural log, and if you look at a lot of these courses in college, they really lean on the natural log. And when we do your logs and we take the log of both sides, you need to take the ln, the natural log of both sides, and you could use the natural log for any of your exponential functions. So if you, and you notice our book tends to use that. It's a college-based book, so it tends to take the ln of both sides versus the log of both sides. You have to use the ln for base E for the natural log, and you can use it for your other ones because it behaves just like a regular log does. Base 3. It's very, very, very close to your base 3. So I just wanted you to see where this comes from and what this looks like. So again, you can graph these in your calculator just so that you see that you can graph base E. I'm not really going to graph and sketch them, but you can use base E just like you would a base of 3 or a base of 2. As a matter of fact, why don't we throw one of these in your calculator just to see what's happening. Not that we could see too much for that one, but we'll throw this in. I'll just throw it in up here. You could throw it in down there. What's nice about your new calculators, it brings everything right up here for you. So it's a little easier than the 83s. So it still behaves like your regular calculators do. This is a stretch, and it stretched out your curve a little bit. It multiplied everything by 2, so there's your intercept. So you graph the same way you do a regular base. Nothing new with that one. We don't do anything else different than you didn't do in Algebra 2. I just want you to realize your base E is your natural base, and it behaves very much like your base 3. Compound interest. You also did this in Algebra 2 as well. This takes on this formula. This is our basic compound formula. This is the shortcut when n is equal to 1, because then we don't need this fraction, and we don't need that one. So if n is compounded annually or yearly, then we could use the shortcut. If it's compounded any other times, we need to put the n in there. Does everybody understand what compounding means? It's a tougher thing to grasp. And I always find that it's really difficult, especially when I taught Algebra 2. 1 plus thing here, this 1 plus, it just rolls it back in. If I invested $100 and I got 10% every year, so I multiply this by 0.10, I get $10. I add it back in, and I do it again next year and the following year, and I have to keep adding it back in. If I instead multiply it by 1, don't I get 100? Isn't it just when I multiply it by 1, I get itself, right? So if I multiply this by 1.10, this automatically accrues my interest. That's where the 1 plus comes from. So if we're doing something with an increase, we want to maintain what's in there. That's why we have the 1. And we want to gain our new interest. That's where the R comes from. If we're decreasing, such as like a depreciation schedule, then it's going to be less than 1 in there. You're going to take your 1 and you're going to minus that rate. So you'll be retaining, if you say you depreciated, and you guys probably don't get depreciation. If you depreciated, say you owned farm equipment, and every year you got to write off part of your equipment, you depreciated it over time. So say it depreciated 5% every year. It's going to decrease it 5% every year. Your 1 minus this says, okay, retain 95% of this. That's where that comes from. You probably saw this in Algebra 2, but really didn't understand why do we add 1, 1 plus R, 1 minus R. So if we're decreasing something, we're retaining the rest of the percent. Does it make sense? No? Okay, say you go into a store. You buy an article. You buy an article in economics, you haven't probably, even your savings accounts, if you have savings accounts, you're not accruing interest like years and years ago. Since all the banks crashed and everything, there's not a lot of interest to be had. But what we do is we use rates that'll show you a substantial difference. Otherwise, you're just looking at pennies difference. So we use rates like 5%, 8%, 3%, 10%. Compounding means how many times am I calculating this per year? And if I calculate it annually, at the end of the year, my interest is accrued in there. If I compound it quarterly, 4 times a year, it's going through that little algorithm to calculate my interest. If I do monthly, monthly is how many times? 12. How about semi-annually? 2. How about quarterly? 4. Good. How about daily? 365. Yeah. And then we also have continuously where our base E comes in. So this is what we're looking at when we do these things. And when we compound continuously, this is where our base E comes in. You learned PERT last year. PERT, your principal, your rate, your time. Okay? And then we use base E. Compounding continuously and compounding daily are the closest.
What is continuously?
Continuously means there's a certain algorithm where they're doing it more than a daily time. They do it. I don't know the exact schedule of it, but it's every time it's recalculated more than daily, more than once a day. But it's the closest to the daily. When we do a daily one and continuously, they're very close. It's been a long time since I took finance in school, in college, a very long time. Okay, so we start same way you did. Actually, this is probably no different than what you did in Algebra 1, in Algebra 2. And actually, you want to hear something weird? In the Common Core, they do this in Algebra 1. They make them do these formulas in Algebra 1. They don't do the continuously, but they do these. So you're given $1,000. This is what you invest. This is your principal. You invested at 8%. There's your rate. After 1 year, this is your time. What is the value of my investment compounded on all these different ways? So we're going to take a look at why are they different. So we have a vested amount of 1,000. How do I write my rate? 0.08. You got to put it in a decimal. Move it 2 places to the left. My time, we're making life simple, 1 year. So now, annually, they're all going to change. Our ends are going to change. N is 1. We're going to use the same formula. Again, when it's annually, you can take the shortcut because N is 1. So, $1,000 times 1 plus your rate. And we don't have to, we could say over 1, and 1 times time will give us 1 times 1 so that you see it. You don't need to put that in there. It's probably just easier to always use that because the only time you go to the shortcut one is with the annual. So if you could put that in and just put it straight into your calculator. And what do you get? Because this is money, how many decimal places should we round this to? 2. This has a natural rounding because it's money. So 1,080. Good. And it's dollars. Okay? If I want to compound quarterly, what's my N? 4. So all you have to do is second enter, bring it back down. Don't retype it. That's why I say keep the same setup, and then all you got to do is change that 4, change that 1 here to a 4, and change this guy. And we're just going to keep the 1, so you don't even have to keep that extra 1. Just second enter and retype it in. 2 decimals. 4, 3. Thank you. Okay. Now we see a little bit of growth. We now went to 4 times a year, so we see a little bit of growth. Even at 8%, that's a small amount of growth. So how about monthly? N is what? N is 12. So same thing, just pull it down, second enter, pull it down, and change the 4 to 12. Remember you have 2 spaces to do it in. And over time, this is just 1 year. Uh-huh. So you can see that even though we're compounding these more often, and we started with our initial investment, and our percent was fairly high, we're growing slightly. Compounding weekly, what's N? Yep, 52, standard. Again, just pull it down and change that last 12 to a 52. You see small growth here. Daily, how many days in a year? 365. We just used the 365. Good. And lastly, we have continuously. Continuously is per. Your principal, base E raised to your rate, 0.08 times your time, which was 1. This one you'll see the largest growth in. But like I said, look how close it is to your daily. It's pretty close to your daily.